Alright friends, in this question we are given in the circuit shown below, the readings of the voltmeters and ammeters will be, there are two circuits given to us, and we are given voltmeters and ammeters here. We have to find out what is the relation between their readings here. So first of all, let's analyze the first figure. We see here that there is an ammeter, resistance of which we will assume to be 0, because let's consider this to be an ideal ammeter, and voltmeter is also mentioned, nothing is given, so we'll assume its resistance to be infinitely large. So that means across these 2 points A and B, when current will enter, some current will enter, none of it will pass through the voltmeter, all of it will pass through the 10 ohm resistance. Current in a parallel circuit, since this voltmeter is parallel to 10 ohm resistance, the current will favor least resistance pathway, so that is 10 ohm will have maximum current passing through it. And since the resistance through, we could simply say that the potential difference across this voltmeter and 10 ohm is same. Since the resistance of this voltmeter is infinity, the current through it will be 0 following Ohm's law, and all the current, say if I is entering through point A, I would pass through 10 ohm resistance, and then that I would be equal to the I1 which is here. So that is the scenario here. So clearly we see that the there will be, and also when this I will pass through this ammeter, there will be no potential drop across the ammeter, because current I would pass through 0 resistance here, so IR would be 0, and then the same current would pass through 10 volt. So that means the potential difference between A and B would be same as the potential drop across the 10 volt battery. That means clearly V1 would be equal to 10 volt. Let's also see what will be I1. The value of I1 will be equal to, clearly from this circuit we see I is equal to I1, and I would be equal to the potential difference divided by resistance. Potential difference across the 10 ohm resistance would be same as 10 volt, and the resistance is given to us as 10 ohm, so this will come out to be equal to 1 ampere. Now let's analyze the second figure here. In the second figure again, the resistance of this voltmeter will be infinitely large, which means whatever current will go from the battery and will come here, none of it will be able to go down, because the net resistance across 10 ohm plus voltmeter would be infinitely large, and most of the current, in fact all of it, would pass through this 10 ohm, and then that current would come out of this, what do you call, this I2. So that means this I2 would be equal to I, and same current would pass through this ammeter. Resistance of this ammeter, let's assume that to be 0 again, so there will be no potential drop across this ammeter. IR would be 0 across this ammeter. The current then would pass through the 10 volt battery. So this is how the current is going. So we see that there is no current going through this lower circuit. So if I mark this point as A and B, this part of the circuit through the voltmeter will not have any current through it. So clearly then what will be the value of V2? Well, V2 would be same as the potential difference across points A and B. No current is passing through these 2 points, that means there is no potential drop across 10 ohm. No potential drop across 10 ohm, no current is passing through 10 ohm, no potential drop across 10 ohm. That means the end A here and this end of voltmeter, the starting end of voltmeter, will be at same potential. The other end of voltmeter is at B, so clearly the potential difference across the voltmeter will be the potential difference across points A and B. No potential difference will come across 10 ohm, because no current is passing through it. So VA minus VB will be the same as V2, and clearly A and B would be having the same potential difference as 10 volt here, because there is no potential drop across the ammeter. So again V2 will come out to be equal to 10 volt, and then we go for the current I2. This will come out to be equal to same as I, and I would come out to be equal to the potential difference across 10 ohm VAB, which is 10 volt, divided by the resistance, which is 10 ohm. This comes out to be equal to 1 ampere. So we clearly see that the voltages are also equal and the currents are also equal. So that means V1 equals V2 and I1 equals I2, which is given to us in option 2. So the correct answer to this question would be option 2. Since it was not mentioned about the resistances of the ammeters and voltmeters, remember the key to this question is the ammeters, their resistance should be taken as 0, the voltmeters, their resistance should be taken as infinite.